Very good afternoon to all of you, my dear friends. I am Venkata Prasad. I am from Andhra Pradesh Social Welfare Residential Junior College, Naidupeta. So, my dear friends, today we are going to discuss the topic Newton's laws of motion and impulse. See friends, before going to discuss our topic, I think all of you are well aware of the words velocity and acceleration. So, let us recall once again. Velocity is defined as the rate of displacement. See here, velocity displacement by time. Displacement is S let and time t by t. Then let us discuss what is acceleration. Acceleration of a body is defined as the rate of change of velocity. See, what is acceleration? Change in velocity is equal to change in velocity, final velocity minus initial velocity by time. This is about acceleration. Velocity, acceleration. Before going to discuss our today's topic, Newton's laws of motion, see here. It is a toy car. Now it is in the state of rest. Its velocity is 0. When I push it, it starts moving forward. That means change in velocity taken place. It is a toy car now. Once again, I am going to say. Now it is in the state of rest. When I push it, it starts moving forward. That means change in velocity taken place. That means the body is accelerating. In the same way, now it is in the state of rest. When I pull it, it starts moving backward. At first it is in the state of rest. When I pull it, it starts moving backward. That means change in velocity taken place. It is moved. That means it is accelerated. Then next, see, it is a ball. Now it is in the state of rest. When I drop it, it starts moving and it is accelerated towards the earth. So see once again. Now it is in the state of rest. When I leave it, when I drop it, it starts accelerating towards the earth. That means change in velocity taken place. The same thing is happening in the earth moon system. The earth is attracting the moon likewise. See examples. See some more examples. when an iron toy car is placed near the magnet, it starts moving forward towards the magnet. That means change in velocity taken place. Then one more example. If a child comb his dry hairs with a comb for a while, if that comb is placed near the paper pieces, we can observe that the paper pieces are getting attracted towards the comb. See, in all of these cases, the bodies are moving, the bodies are accelerating. The change in velocities of these bodies are taking place. So that means a property is acting between the bodies. A physical quantity is acting between the bodies. That tends the bodies to accelerate. That means unless something acts on it, they will be in the state of rest. So something acts on it. See. So in all of these cases, the bodies are moving. So in all of these cases, the bodies are moving. So the reason behind the motion of these objects is nothing but force. In common language, force is the push or pull of one body on another, causing acceleration. So see here, in the case of pushing and pulling of a toy car, the mechanical force is involved. In the case of iron toy car placed near the magnet, the magnetic force is involved. In the case of paper pieces and the magnet and the comb, the electrical force is involved. In the case of ball dropped and in the case of earth moon system, the gravitational force is involved. So from all of these examples, we can observe that these unbalanced forces are responsible for accelerating bodies. That is, otherwise the bodies will be in the state of rest unless the force acts on it. So these forces are responsible for accelerating bodies. That means every body which is in the state of rest or in the state of uniform motion in a straight line will remain to do so unless and until an unbalanced directional force applied on it. Without understanding the concept of force, I think it is meaningless of studying Newton's laws of motion, and hence beginning I explained you different kinds of forces which are responsible for accelerating bodies. If an unbalanced directional force is acting on an object, it would speed up, slow down or changes its direction of motion. So these unbalanced forces are responsible for accelerating bodies. Then next, if in fact Newton's first law of motion states that change in velocity, force changes the velocity of an object. See Newton's first law of motion. Every body which is in the state of rest or of uniform motion will remain to do so unless and until an unbalanced directional force applied on it. This is nothing but Newton's first law of motion. In fact, Newton's first law of motion states that a force changes the velocity of an object. Then let us discuss an important concept, that is inertia. Inertia is the property of an object which resists the change in its state of rest or of uniform motion in a straight line. if the mass of the object is larger, it is more difficult either to move it from its state of rest or to stop it when it is in motion. Hence, mass is noted as the unit of inertia, the measure of inertia. Then see, let us see some experiments. Place a tumbler partly filled with water on a paper. If the paper is given a pull, the tumbler starts moving towards along with the paper. If the paper is given a quick sharp downward pull, the paper can be removed without spilling the water in the tumbler. See, at first it is in the state of rest. So, with the property of inertia, it resists the change in its state of rest. So, the paper can be removed without spilling the water in the tumbler. See one more example. It is the water tumbler. Place it on a table. See, it is the plastic lid. Place it on the water tumbler. A ball supported by a narrow pipe is placed on the plastic lid. If the plastic lid can be removed, the ball falls into the tumbler beneath. See, at first the ball is in the state of rest. So, with the property of inertia, the body resists the change in its state, and hence if the plastic lid is removed, the ball falls into the tumbler beneath. That is, so in both of these cases, the property of inertia at rest is occurred. Then see one more example. See, in this example, when a person is driving a topless car, with a great speed, when the topless car is stopped suddenly, he is in a danger of being thrown over the car. That means every body in the state of uniform motion will remain to do so unless and until an unbalanced external force applied on it. So, if that car is stopped suddenly, he tries to move in the same velocity, automatically he jumps away from the car with the property of inertia. So, from these three examples, in first two examples, the property of inertia of rest is involved. In the next example, the property of uniform motion, the property of rest, the property of inertia of uniform motion is involved. Then let us discuss the consequence of the significance of Newton's first law of motion. A fast bowler runs through a reasonable distance before the delivery of the ball, thereby imparting a great speed on the ball. The bowler has taken the inertia of his moving body as an advantage, and hence Newton's first law of motion is also known as law of inertia. Then see one more important topic. When a badminton player misses a ball, it hits him, but it does not hurt him even if it hit hard. In other hand, a small mass such as a bullet can kill a person when it is fired from a gun, and also a lorry can kill a person who is standing in its path, though the lorry is moving quite slowly. Momentum is a vector quantity and it has the units kg meter per second, and it will be shown with an equivalent Newton second. So, from this property of momentum, an important law is arising. That law states that the rate of change of momentum of an object is equal to the unbalanced external force applied on it and acts in the direction of force. See, listen to me carefully once again. That law states that the rate of change of momentum of an object is equal to the unbalanced external force applied on it. This law is nothing but Newton's second law of motion. See, let us discuss what is Newton's second law of motion. Change in the rate of change of momentum final momentum minus initial momentum by time. See, at first we discussed that the rate of change of velocity is nothing but acceleration, and hence therefore the rate of change of momentum is equal to the unbalanced external force applied on it, that is Newton's second law of motion. So, force F is equal to ma. This is the expression for force F is equal to ma. Force has units kg meter per second square, and it can be also written as Newton. It is defined as Newton. Why? Because as a tribute to a great scientist, Sir Isaac Newton, about whose law we are discussing now. It follows that, see in this example, see here, when a person pushes the car of mass 1000 kilograms, and if with his push the car is accelerating with acceleration 0.05 meter per second square. So, now we have to calculate the force applied by him onto the car. See here, the mass of the car there is 1000 kilograms. Then acceleration of that car is equal to 0.05 meters per second square. So, we already derived the expression for force force F is equal to ma. So we have to substitute these values in this expression, then we will get the answer. Then mass equal to 1000 kilograms into acceleration 0.05, that equal to 50 newtons. Then let us discuss the Newton's third law of motion. Forces, forces come in pairs. If you walk on the earth will pushes you in response to your push on it. See, you are walking, if you are walking on the earth will pushes you in response to your push on it. So the situation can be summed up with gentle words. You cannot touch without being touched. You cannot touch without being touched. Okay, see here. Actually, Newton's third law of motion states that for every action there is an equal and opposite reaction. See, let me repeat once again. For every action there is an equal and opposite reaction. The action and reaction, the words used here are nothing but the force. So using different words for the same physical quantity may be confused by us. So that's why the Newton's third law of motion should be in the following way. See here. See here. When a body A exerts a force FBA on B, when a body A exerts a force FBA on B and B exerts a force FAB on A, these two forces are equal in magnitude but oppositely directed, and hence so this situation can be written in the following way. See here. FAB is equal to minus FBA. FAB is equal to minus FBA. So I already told you that these two forces are equal in magnitude but oppositely directed, and hence here the negative sign indicates the opposite direction. See some examples. When a ball rests, see there, when a ball rests on a box, it pushes the box with a force equal to its weight, and the ball exerts an equal and opposite force R to that ball. So see here, we have to note that two objects are involved, two equal and opposite forces, two forces act on different objects, never on same object. So the two opposing forces are sometimes called as action and reaction forces. Then see, in the case of ball, see there, in the case of ball and the table, see there, in the case of ball and the box, the ball